we have come up to the three differential equations we have solved using our Schrodinger's equation by separation of method. Okay, and these three differential equations now we have to solve and come to the final result. See, what these are the three differential equations last we have solved. So these are the one. So d2z by d phi square plus ml square z is equal to 0. So this differential equation from phi. So this is the phi differential equation. Another is the theta 1 upon sin theta d theta by d theta sin theta dy by d theta plus L into bracket L plus 1 minus ml square divided by sin square theta y is equal to 0. So this is the differential equation totally depends on theta, and this is the radial form of the differential equation. Okay, now we see one by one and see what happened for the final result. So consider this result, and solution of this result is this z of phi is equal to a e raised to I ml phi, e raised to I ml phi, where a is a normalization constant. A is a normalization. This value of the normalization constant we have seen last time as 1 upon root 2 pi. That is here also we can calculate, but it will become more time that we have last time we have solved it. So this is the 1 upon root 2 pi. Okay, so by integrating this value of the dx we will get a 2 pi 1. Now, and therefore this z of phi is equal to 1 upon root 2 pi e raised to I ml phi, e raised to I ml phi. So this is your the expression form. And there is another property for this is, so this z of phi is equal to z of phi plus 2 pi. Means after the rotation of 2 pi angle, we came to the same point. We came for the same point. So according to this, z of phi is equal to this one, and therefore z of phi is equal to what? So this is the 1 upon root 2 pi e raised to I ml phi is equal to z phi plus 2 pi. So this is 1 upon root 2 pi e raised to I ml phi plus into e raised to I 2 by ml, e raised to I 2 by ml. Okay, so this is equal to 1. Okay, and therefore this will cancel and is equal to 1. So e raised to I 2 pi ml is equal to 1, and that can be written as a cos of I ml phi, cos of ml phi. So this is the cos of ml phi minus I sin of ml phi is equal to 1. So for 2 pi angle, 2 pi ml. Okay, sin this sin 2 pi ml minus I sin 2 pi ml is equal to 1, and therefore this is equal to 0, and therefore this is 1, and this is possible for the angle ml is equal to 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, and so on. And this ml is called magnetic quantum number. So this is magnetic quantum number. Okay. When the question came, what is the magnetic quantum number? You have to write this. Okay, so this is the one magnetic quantum number. So from this equation we come to this result. Now consider this second differential equation. This is second, you see this differential equation. So this is the 1 upon sin theta d by d theta of sin theta dy by d theta plus L into bracket L plus 1 minus ml square by 2 ml square divided by sin square theta y is equal to 0. So this is the associated Legendre equation, and therefore this associated Legendre equation can be solved by substituting x is equal to cos of theta. That exercise we also in residual rotator example, and when we substitute this x equal to cos theta, then we come to the final result. So that is the 1 minus x square. So this is the d2y by d theta square. D theta square plus minus 2x dy by dz minus 2x dy by d theta. Sorry, dy by dx. X dy by dx, then plus L into bracket L plus 1 minus ml square divided by sin theta, and sin theta is nothing but the 1 minus x square okay, is equal to 0. So this is the associated Legendre equations, and solution of this Legendre equation we have already known, and I am writing directly this one. So this y L ml of theta, so y L ml is equal to a b of p ml, this a cos of theta, p ml of p l ml a cos of theta, where b is a constant, and this normalization constant value of the b is b is equal to root into bracket 2l plus 1 by 2. So this is the 2l plus 1 by 2 into bracket into L minus a mod of ml bracket completed. Okay, and this L plus modulus of ml factorial. Okay, so this is the value of b. This is the value of b, and from that we can find the solution for this y and z ml. And third equation is 1 upon r square d by dr r square d by dr plus 2 mu h bar square e plus e square by 4 pi. So this is the effective solution. Okay, and r is the distance between nucleus and that of the electron. If we consider as in case of last time also we have seen, so this first term derivative is equal to 0, and therefore this is equal to 0, and this equation is give a n number of solutions, but this is a valid acceptable solution at energy E equal to En. E is equal to En, and what is that value of the energy En? Is equal to minus mu e raised to 4 divided by 4 pi epsilon naught square. It is h bar square n square. This h bar square 2 h bar square n square. So this is the 2 h bar square n square. So En is equal to, so this valuable or acceptable solution is only possible for E is equal to En is equal to minus mu e raised to 4 divided by 4 pi epsilon naught square 2 h bar square n square, 2 h bar square n square. If we find out all putting these values, we come for the minus a 13.6 n square e electron volt, and which is exactly the result which is coming from the Bohr formula. Means from this a quantum mechanical treatment, whatever the energy come for the ground state is a minus 13 point E n square electron volt, where this n is called the principal quantum number. So this n is equal to 1, 2, 3, n. So we come to three quantum numbers. One is the principal quantum number, n is equal to 1. Another is L, angular quantum number, and third one is a magnetic quantum number. A is for magnetic quantum number. So this value of L is equal to n minus 1, and this value of L is the minus ml to the plus ml, So this is a correlation between these quantum numbers. So this is your to find out the eigenvalue problem. Okay. Next, so we have a general solution. So psi of r theta phi is equal to a product of. So this is the general wave function for our system for hydrogen atom is equal to a multiplication of the three wave functions. So r of r, y of theta, and z of phi. And so this r of r we have find out from our radial component, and that solution for the radial is n e raised to minus alpha r. Okay, so alpha r raised to L is our the radial form into L into alpha. So this is the radial form. But this n value of the n is given as n is equal to root 2 divided by n a0 cube n minus L minus 1 factorial divided by 2n into bracket L plus 1 bracket complete factorial total raised to cube. Where this a0 is Bohr radius, which is given as 4 by epsilon naught h bar square divided by 2 mu divided by mu e square. So this is the value of the Bohr radius a0. So all this is we have written in terms of the Bohr radius. And second part is BPL, so y of theta. The second solution, B a PL of theta cos of theta, and where B is value we are already known into A into e raised to iml phi, A into e raised to iml phi, and this value of the A is equal to 1 upon root 2 pi. Okay, and so this is the phi, theta, and r. When by putting this value n, l, and m. Okay, in this value, when we are putting L is equal to 1, then L is equal to 0, M is equal to 0, then this is the ground state wave function. Psi 1, 0, 0 is equal to 1 upon root pi a cube e raised to minus r by 0. So this is the ground state. To solve this, this is the exercise for the MSc. But for your the examination point of view, you write you take here directly. And the second state is a 2 0 0 2 1 1 2 1 0, and here the 2 1 plus minus ml. So here also this plus minus ml means again two equations will solve here. That is written in terms of the plus minus I theta, and these are the three different equations according to the sign. This is called the first excited state. In third excited state, what happened? 3 0 0 3 1 0 3 1 plus minus 1. So second excited state is 3 0 0 3 1 0 and 3 1 plus minus 1. 3 1 plus minus 1. So this gives the third second excited state. So psi 200, psi 210 and psi 21 plus minus 1, which gives a second excited state, and corresponding these are the wave functions. So this is a hydrogen atom. In whole article is a total mathematics. So please go to the repeatedly solve it, so that it will come in your hand and you can easily write in the examination. And one big question will come on this hydrogen atom, and only qualitative. So there is no derivation is required from you. Only whether you are to understand this hydrogen atom or not. Once you understand hydrogen atom, just say I say in your introduction. So this is a very simplest form of a hydrogen atom in a periodic table. Then you analyze that we considering it is the simplest form, but when we are going to solve this all mathematics, so you are get bored. Okay, and therefore instead of the boring, you apply for the Z is equal to 2, 3, 4 and then multiple electron system. Then spectral analysis, for the spectral analysis, these equations are the very important point of view, and therefore so this is the hydrogen atom in using the solution method, so using the Schrodinger's equation. In higher quantum mechanics, this hydrogen atom also solved by a operator method. So that is not even for syllabus, it is for the MSc. So this is your article, hydrogen atom, for solve the hydrogen atom using the Schrodinger's independent equation.